Good morning, or good afternoon, or good evening, depending on exactly where you are in the world. And welcome to today's Information Week webinar, The Network of the Future is Powered by AI. This is sponsored by Mist Systems and Juniper Networks, and it's being broadcast by UBM. I'm Lenny Lieben with Information Week. I'll be your moderator today, and I'm just going to make a few logistical announcements before we get started. First of all, the webinar is designed to be interactive, so you see the dock of widgets there at the bottom of your screen. That'll allow you to learn about today's speakers, to download resources, to share this webinar via social media, and also to participate in the Q&A session that we're planning to have after our presentations. Now, please do not wait until the Q&A session to input your questions. Go ahead at any time at all during the event. If one of our speakers says something you want them to elaborate on, if they make an assertion you would like to challenge, anything at all, again, please feel free to get your questions in early and often so they're in the queue. Also, you should know that slides advance for you automatically throughout the event. You can also download a copy of the slides using that resources widget. And also towards the end of the webinar, we'll ask you to complete a survey that's on the right-hand side of your screen. Please take a minute to fill out this survey before leaving us today, because your feedback really helps us continuously improve our future events. And lastly, if you're experiencing any technical problems, just check the help widget at the bottom of your screen, or you can just type into that Q&A area and we'll see it as a question. We'll be glad to offer you some one-on-one assistance. So that's the logistics. Let me introduce our awesome panel today for the Network of the Future is Powered by AI. Discussing today's topic are Jeff Aaron, who's a VP of Marketing at Mist Systems. He's got a great background in all kinds of storage acceleration and analytics, and especially is taking charge of Mist's really innovative wireless platform. Then you're going to hear from Rahul Veer, who is Senior Director of Product Management at Juniper Networks, where he's in charge of product and corporate strategy and portfolio management, enterprise networks, knows a lot about NFV, network functions virtualization, and service provider networks. So whatever scale you're working at, Rahul can provide some answers. I think he's been with Juniper for more than 6 years and got his MBA from Berkeley. So those of you in the Bay Area can be proud of Rahul. We have with us also Mitch Davis, who is VP and CIO at Dartmouth. So many of you may have heard Mitch before, because I've heard him a few times on previous webinars. A great speaker with a great perspective, and he obviously provides campus-wide vision and leadership and direction for the use of technology at Dartmouth, which also includes not only that college, but also Thayer Engineering and Tuck Business School and Geisel Medical School. And we'll also hear from Felix Wint, who is team lead for network engineering at Dartmouth. Has to make real what Mitch imagines and puts on paper. So he's a real great network infrastructure technology expert who not only is going to give us a good presentation briefly, but also is a great guy to ask questions. So with all of that introing out of the way, Jeff, I think you're going to kick us off. So why don't you go ahead and get started?
Yeah, thank you so much, Lenny. Yeah, I'm excited to be here. We've had the chance to work with Rahul and the Juniper team and Mitch and Felix and the Dartmouth team, and it's a great bunch of folks doing some great things, and I'm excited to talk about some of those items. I mean, the impetus behind why we all got together and why we're working together and why we're chatting here is the fact that the old IT service model, for lack of a better term, is dead. The old reactive network-centric model is quickly being replaced by one that's more automated with more insight into the user experience. And I think recently there was a Gartner CIO survey here which kind of validated that, where we asked the CIOs what their top business objectives were. It's all about growth, lowering costs, and using digital transformation to kind of bring in new experiences and kind of raise the brand. And obviously Mitch is one of those CIOs, and we can chat with him later about some of those initiatives. But taking that one step further is, if you ask them, what are the top projects that kind of led to those initiatives that really are driving, whether it's a school or whether it's an enterprise or whether it's a hospitality location forward, there's several here on the left. But what's interesting to me is, 4 key themes kind of bubble to the top. And that's what you're going to hear throughout the conversations when I present on the Mist story, when Juniper Rahul presents that story, and then ultimately when Mitch and Felix kind of bring it all together as to what they're doing on an end user perspective. But those key themes that I think are the most important that we're seeing are, one is a need for more insight. And with the amount of data out there and the amount of devices out there, you really need AI to do that. AI to really, collect all that data, prevent you from having to hunt through dashboards and correlate all that information so you can get meaningful action out of that raw data. So AI-driven insight is number one. Number two is we are seeing more of an emphasis on mobility, which is obviously near and dear to Miss Heart. More and more enterprises and companies and schools are going wireless first, cutting the cord almost entirely in terms of wireless to the desktop, and that creates a new mobile opportunity. But also, it's all about the mobile experience. So not just the device, but what is that user experiencing on the network, and how does that translate to a better opportunity there. The other thing that we're seeing is a move to the cloud. In particular, moving away from on-premises hardware where possible to the cloud, where it's all about more elastic scale and cost efficiency and just a little bit more dynamic nature, and I think that's a trend we're seeing. And then the last one is a move towards more of a DevOps mentality when it comes to IT. It's all about programmability, it's all about automation, less about, again, that UI experience and more about taking that data and moving it into workflows and working across the entire stack for better visibility and better automation and insight. And in fact, again, that's why we're all chatting here today. There is a goal to take that AI, that automation, that insight, and move it across the whole stack. And what I'm going to talk about is, Miss is doing that on the wireless side. We have an integrated AI engine that is helping to create a better mobile experience. And what we've actually been doing is working with Juniper to kind of extend that across the wired domain and the WAN domain. So you get a kind of common experience across the wireless and wired device, and as well as bringing in security. And then again, at the end, we have Dartmouth that's going to come in and talk about what that means to them, how they've been able to, implement some of these solutions, and actually going forward, what the vision is for kind of AI for IT across the whole stack and where they want to take that. So that having been said, I'm going to jump into the wireless piece, and then we'll hand it off to the other guys to kind of talk about their domains. So what's interesting from a wireless standpoint, if you actually look at the different infrastructure areas, this is probably the one that's perhaps most in need of this new move towards an IT service model, around automation and insight. And there's really two reasons for that. The first is that just quite frankly, wireless Wi-Fi is in need of innovation. For 10, 15 years, the same solutions have been out there, and they've had a lot of the same issues that have kind of led to some of the problems we've had today. One is the fact that they're very network-centric. So if someone walks onto your campus or walks into a hotel or walks into an airplane even, and they're having a bad experience and they complain, typically the IT department has the ability to kind of pull up a UI dashboard and say, well, the access point is green, you should be having a good experience. And the problem is up is not the same as good. Just because the network is up doesn't mean the user is having a good experience. So the first thing that you need to do with AI and Wi-Fi is to make it more user-centric. Take it out of the network experience and move it into the user experience so you have a better metric. How long is it taking my users to connect? How long is it taking them to roam? What is their throughput? Are certain device types having issues? That's the level of visibility that you need for Wi-Fi, which is transitioning to this new world order. Aside from that, it's just really upgrading the infrastructure, the architectures, so they're just more designed for the smart device era. Ideally moving away from on-premises controllers so you have more scalability, you have more predictability, more reliability, more cost effectiveness by moving to the cloud. And so again, that's what we're seeing today with the ultimate goal of using an AI-driven wireless platform in the cloud to make Wi-Fi more predictable, make it more reliable, bring in an element of self-healing, and then just, again, ultimately make it more measurable in terms of the user experience. But the other thing that we're seeing that's also interesting is that wireless isn't just about connectivity anymore. It's not just about people getting onto the network, getting access to the internet or to their applications or their gaming or social media. Wireless has become about experiences. And primarily it's about personalized location-based experiences. If you think about it, outside of the indoor world, we're used to wireless knowing where we are and delivering personalized experiences. Think of Google Maps and Waze as a perfect example. The problem is once you walk indoors, that breaks. And to date, there's really been two ways of doing indoor location. There's Wi-Fi, which, to be frank, we've been trying for 15 years and just really doesn't work. It's very expensive. So the alternative is Bluetooth. And the problem with Bluetooth location is you have to put battery beacons on the wall every 15, 20 feet, which is not a real scalable solution. They're battery-powered beacons. They fail. It's not a scalable solution. So if you can actually virtualize the Bluetooth location experience, moving into the same access point as you're delivering Wi-Fi, all of a sudden you're able to open up a whole variety of new realms for wireless that creates new experiences on your network that adds value to the wireless network. So, for example, if you're a hotel like Disney's Walt Disney World Swan and Dolphin in Orlando, you can greet people when they come. You can check them in. You can give them turn-by-turn directions to their room. Similar, if you're a retail environment like PetSmart, you can check someone in. They can hit a button, get a sales associate. As they walk around, they can get coupons. Or healthcare, the Orlando VA, greet patients, find wheelchairs, lock doors if dementia patients are walking towards an exit without a nurse nearing them. And similarly in higher ed, again, Mitch and the team will talk about Dartmouth, but some instances for not just Wi-Fi for location could be self-guided tours, analytics as to where students are spending their time. Do I need more security guards in certain areas? So again, it's not about connectivity anymore. It's now about enabling new location experiences using Wi-Fi in your network, and AI in the cloud really helps that. We do get asked all the time, why would you create a new wireless LAN solution? There's obviously plenty of vendors out there. Mitch and team obviously, did some evaluations looking at some of the big boys out there. But it's interesting, if you actually take a step back, it becomes fairly apparent why there's need for innovation in this space. I was at Airspace in 2003. That's when Intel came out with Centrino. And that's actually where there was a whole host of innovation in wireless. That's where the controllers came out with Airspace and Aruba. Shortly after that, there was other vendors that came out with Ruckus, Aerohive. Even Meraki, the first cloud, came out between 2003 and 2007. What's interesting is every one of those platforms, this is 90% of the wireless LAN market today, was all built prior to 2007. So think about that. They were built prior to the modern cloud. Amazon came out in 2007. They were built prior to the modern smartphone. That wasn't launched until 2007. Virtualization didn't come out until that time frame. GPUs didn't come out for AI. Bluetooth Low Energy didn't come out until 2016 and become a standard on both Apple and Eddystone. So there's just a whole host of innovation, a decade of innovation that the wireless LAN experience has completely missed out on, which is why we created our solution to go after that. So what we do sell is we actually do sell access points that go on premise. They are a combination of either Wi-Fi and BLE or BLE only. And these access points are literally collecting over 150 user states from every mobile client every 2 seconds, and they're moving that to the cloud where you can get actionable insight. It is worthwhile to point out that this is a modern cloud. We looked at how Netflix and LinkedIn and Google built their cloud using containers, using microservices, using Storm, Spark, Kafka for resiliency and agility, and that's how we built our cloud. And the other key thing is, so in addition to all those features, this also lets us do AI in the core, in what we're doing, for things like event correlation, for predictions, for actionable insight, for anomaly detection. Again, this is the way of building a modern wireless network, and it gives the core for that AI functionality that you can then extend to Juniper and your security domain and other areas to get AI automation and insight across your entire IT stack. And key to that is open programmability using APIs, so we can share this information with each other and, again, create a cohesive story. So ultimately, again, winding down a little bit, when you have an AI-driven wireless network, again, it literally changes the game in terms of what you can do with Wi-Fi. And again, Felix and Mitch are going to go into more detail here. But some of the examples are, for the first time ever, you can do measurable, customizable service levels. So again, how long is it taking my users to connect? Who's not connecting in that period of time? Are certain devices having problems? Are certain operating systems or certain parts of my networks having problems? Service levels, delivering Wi-Fi as a service level is finally here. Similarly, you can do things like event correlation. If something goes wrong, was it an issue in the wireless network? If so, was it coverage, capacity, what was the issue? If it wasn't a wireless issue, we want to help folks like Felix figure out, okay, it was a DHCP issue. It was an internet issue. Our devices are having problems. So rather than him having to chase his tail figuring out where the wireless problem is, we want to take all that information, correlate it for him, use AI, so he has all that handed to him on a silver platter so we can troubleshoot the issue, get to the root cause, and fix it that much easier. As part of that, we've also even offered the world's first virtual network assistant called Marvis. So literally you can type in simple questions like, what was wrong with Jeff's iPhone last week? What's wrong with the access point in the corner? How many of my iPhone users are having throughput issues? And we give you that information in an easy-to-use format. And the last thing is tying in those location services we mentioned. So now all of a sudden you have Wi-Fi tied in with location, you can do some pretty amazing things, which again, Mitch and those guys can talk to. And we can also talk to some other use cases as well. So for example, as we mentioned, PetSmart waking up that app, Swan and Dolphin greeting customers, the top e-tailer in the world being able to just automate their Wi-Fi experience, so if something goes wrong, they can create trouble tickets and create workflows. The list goes on. And again, I won't necessarily go into these here. We have the Dartmouth team here to talk about their example, and we can talk about other examples offline. Also, we do a webinar every week, a Wireless Wednesday webinar, where we do give more examples, so we encourage you guys to go to our website and tune in for that. Okay. And then the last piece is, as I hand this off to Juniper, is, as we mentioned, is the ability to take that automation, take that insight, and hand it off to other vendors that are critical to the stack. So in the Juniper world, the goal is to really give you a unified view from your wireless domain to your wired domain across the WAN. Rahul will go into that a little bit more detail in a second. I just wanted to cue it up and say this is an area of integration that we've been working with, and we're excited that it's come to fruition, and end users like Dartmouth are able to leverage that. So again, wrapping this up, MITS is the first AI-driven wireless LAN. We've been really able to take the industry by storm with a cloud-based approach with AI in the core for automation, for insight, and for location services. Excited to work with vendors like Juniper to bring it across the stack, and with end users and partners like Dartmouth to put it into fruition. And so that having been said, let me hand it off to Rahul, and he can talk a little bit more about the Juniper story and how that fits into the equation.
Okay, excellent. Thank you, Jeff. This is Rahul. I'll spend the next segment to share some insights about the software-defined LAN, or the SD-LAN in short. So let's first start with the secure and automated multi-cloud. Now, if you look at where the enterprises are today, they have the main job is to provide secure connectivity from the campus and branch to the multi-cloud infrastructure. And that's where the applications are, right? So it could be in the private cloud, they could be in IaaS hosted infrastructure, or delivered via SaaS. So now for some, multi-cloud might just say, oh yeah, it looks like a data center to me. But multi-cloud view extends way beyond the data center. So, a typical cloud strategy would include 4 pillars. So the cloud delivered enterprise, and that is, typically the campus and branch, the distributed cloud, the secure connectivity to the cloud, in many cases people call it the software defined WAN, and powering the cloud data center. So that's the 4 pillars. And only by considering all the elements of the multi-cloud end-to-end does an IT organization bring the full set of requirements to consistently and uniformly secure and operate the network. Now, the long-term mission of software-defined network technology is to use the technology to simplify the network, or get to a state of this self-driving nirvana, right? And as enterprises or cloud networks evolve, they expect it to take the 5-step journey. And this 5-step journey, if you look from left to right, it starts from the human driven. And if you look at majority of the networks today, the networks used to always be deployed using manually configured devices using CLI with highly trained engineers. And some people have moved away from that, some people are still on that one. And over time, the configuration, what happens is, it's done by a diverse set of administrators, and it deviates from this initial structured view and becomes unmanageable. So cloud providers took the lead in this second category, in where they use scripts to automate the workflow. So the cloud providers, they started using Ansible playbooks to set up the entire network, and then took the approach of treating these devices as cattle versus pets. Basically, you can remove a device and then put another one. It'll automatically, the Ansible playbooks will reset the device, and everything will get set again the way it's supposed to be. And that's step 2. But as networks evolve, dynamic actions can now be taken based upon the quality of experience and application performance. So if you look at software-defined WAN, SD-WAN as an example, it has employed this to provide better experience by steering traffic dynamically across multiple links. If you have a broadband link and an MPLS link, you can dynamically steer the traffic based upon which link is actually better suited for that specific application at that time. And networks have further evolved. So that's where the event-driven comes in, right? And then if you go to the next step, the networks have, over the last few years, evolved to include streaming telemetry information, and that's the information about the state of the network. Now, there's a large volume of data that gets generated, and that's typically not intended for human consumption. You use machine learning to generate actionable insights out of that. Now, all of this is designed to get to the goal of self-driving network, which is step 5, where businesses define the intent, and the network automatically gets to set the authorized users connected to the applications. Now, if we look at where the companies are, we see majority of people are somewhere between stages 2 and 3, and that's where and it's a journey. And the enterprises self-select in where they want to be today, and then where they, and the end goal, of course, being getting to the self-driving network stage. So going to the next one is starting with software-defined LAN. Now, there are few building blocks for what software-defined LAN is. There's the physical layer, and this is the physical layer of the network. This is the access layer where all the devices are connected. So the devices could be desktop, access points, surveillance cameras. Now you see a lot of IoT devices connecting inside enterprise network, inside a campus. You could have door locks or all the other smaller devices connected in there. And the typical requirements that come in is multi-gigabit Ethernet speeds, because the upcoming 802.11ax standards, the speeds would go higher. Gen 2 PoE, which just got approved, so it can power higher powered devices, going all the way to over 90 watts. And those are the recent requirements that come up. And then there is the campus fabrics. Now, they play a vital role in the architecture decision for many cases. Now, customers, we see them picking fully automated fabrics like Junos Fusion, where the entire fabric, the entire network looks like a single device, and that provides simplicity. Or some customers, some enterprises pick IP fabric with EVP and VXLAN as overlays, and they use the automation tools co-developed with the data center teams. Right, and that's the choice. Wireless evolution obviously is very well covered by Jeff. Analytics is the next important piece, as across the network, is to be the network switches, routers, firewalls, and they're now generating a large amount of streaming telemetry data that is analyzed in real time to generate these actionable insights. Now, on the left, you see the access control piece. Now, the traditional authentication function has expanded now. It's expanded to device fingerprinting to determine the type of devices, assigning the proper network segment for these devices, and of course, programming these dynamic policies in the network. That's the software-defined LAN piece. Now, going a little bit deeper into the fabrics, the popularity of IP fabrics and standard-based overlays using EVP and VXLAN has increased, and there's a few reasons for it. The first one, as you can see on the left, is many campus networks are migrating to an EVPN core. A simple extension of EVPN to the campus and distribution brings in a lot of benefits, like you get multi-homing, automatic multi-homing inside the network, so you can where customers will be using a proprietary technology for multi-chassis into two different chassis, like MC-LAG. They now can use the native capabilities of EVPN. The second one is enterprises. We see wireless LAN moving to a controllerless model, away from these, the past legacy technologies. And now some analysts are predicting that by 2021, 40% of networks will become cloud managed. Now, combining the controllerless WLAN design with the VXLAN layer 2 overlays has the potential to create an infinitely scalable network. And then the third one, and the last one, but very important, as the campus access piece adopts the VXLAN, you get layer 3 all the way to the access. So you get the robustness of layer 3 all the way to access. And So and that's really important for some of the IoT devices, and in many cases, the industry shop floors, you have robots which actually prefer layer 3 in many cases, and you can still use layer 2 because with the overlay, it can provide loop-free layer 2 access for specific applications that must remain at layer 2. Okay, now let's delve a little bit deeper into the IP fabrics. Now, the IP fabrics, the popularity of IP fabrics and EVP and VXLAN is largely owed to it being an IETF standard, along with its widespread adoption inside cloud and provider networks. If you look at these networks, the support for this is available in the Juniper EX and QFX switches, as well as the MX routers. Right? So it's part of Junos, and it's available across the enterprise portfolio. If we take the example of core and distribution being part of the IP fabric and use VXLAN overlay for segmentation, the access devices can automatically assign port profiles to ports connected to the wired devices as well as missed access points. And the access layer out here, if you see at the bottom, which is using virtual chassis in the wiring closets, connects with this fabric using lag. So as the lag connects, the EVP and VXLAN fabric provides layer 2 segmentation and is able to maintain the subnet across a large EVPN network, making the roaming seamless. Now, and also with the addition of new things to the portfolio, which includes multi-gigabit speeds, which is the 5-speed in the access platforms, 100 meg, 1 gig, 2.5, 5, 10 gig, the network becomes ready for 802.11ax as it comes up next year. Okay, so a little bit more about policy and segmentation. So campus networks are evolving fast, and the requirements are changing, especially for the guest access and building management and IoT. So if you look at a lot of these IoT devices coming in, there's a wide variety of these devices, which can be smart devices that have an endpoint security client. This could be devices that are very lightweight and they cannot have a security endpoint inside that. So the functions need to be a little bit different. So if you take an example of a thermostat, it can either connect to the internet or it can connect to the HVAC controller. Thermostats should not be talking to each other. That's a security problem. So providing the right access in the network becomes really important. And the administrator, but to get the network to that simple state, the administrator just has to specify the user groups and policies. And with automatic device profiling, that can be done using traffic patterns from the devices. Is to correct user group, they can actually assign the policy on the network access control software. So a NAC software like ForceGuard could actually take care of that. So that's uniform policy and segmentation, which becomes more important in the network as it's changing with the different kind of devices coming in. I want to touch a little bit on the analytics piece because we already talked about the network layer, the fabric choices, and the access control. In a well-functioning network, advanced telemetry features like we talked about the Junos telemetry interface or JTI, which is streaming telemetry, along with traditional information that comes in through syslog and sflow, and taking that real-time information into Contrail analytics, the administrator can define the business intent and use all of this streaming telemetry data and determine the current state of the network and determine that if there's a failure likely in the network, and it can either provide actionable insights, which can take a proactive action, or tell the user, hey, you need to take an action out here, even before the problem shows up. So that's where the analytics comes and makes the network more proactive and better. And I'll just touch I'll touch on a couple of solutions that we've done together with Juniper and Mesh together. So one of the solutions, the first one is for the medium and small enterprises. In this solution, we have Sky Enterprise and Mesh Cloud on the top, and the campus and branch networks, which consist of the LAN and WAN can be planned, deployed, and monitored using Sky Enterprise. The underlying hardware, which includes the EX series switches, the SRX series routers and firewalls, and the best access points. And if the enterprises are already using these devices, they can enhance the experience by adding the cloud management with Sky Enterprise, which provides full management for secure routers, firewalls, and switching. And this used along with the MultiCloud can manage the entire LAN, WAN, and the WLAN piece. And the solutions, as we talked about, they are all ready for future with multi-gig access ports, as well as the new 802.3 BT 95-watt PoE standard. And then the last solution I want to talk about is this is for the large distributed enterprises. Now, and this is one of the examples which Jeff also showed earlier, where Contrail Service Orchestrator is integrated with MultiCloud. So Contrail Service Orchestrator manages the SD-WAN network, and along with MultiCloud, it manages the entire WAN as well as the LAN piece of the WLAN piece of the network. And in that, it can provide AI-driven insights for users to connect through the WLAN, LAN, and SD-WAN. So if there's a problem in any part of the network, so if there's a problem in user connecting or a problem between the user, the access point to the LAN or LAN to the WAN, or if one of the WAN links is down or some problem there, all of that can be detected directly. So that's this just a couple of solutions. There are obviously more solutions that we have, and I wanted to highlight these out. And I want to sum up with that as the enterprises go through this 5-step process of simplifying their journey to multi-cloud, the SD-LAN becomes a key component to it. So I'll at this time, yes, firstly, thank you, and at this time I'll hand it over to Felix and Mitch to provide insights from Dartmouth College Network.
Hi, all. Pleasure to be here. My name is Felix. I'm a network engineer at Dartmouth College. I figured, because I'm not entirely sure how many of the attendees here are aware exactly of how complicated campus networks works in higher ed, I just wanted to give a quick overview kind of what we have to address as problems. We are well over 90% residential for undergrads, so those are the students that just expect that they have full access to any of the learning management systems that they use, or the classroom technology facilities that the faculty use to teach them. But at the same time, they live here for 4 years. This is literally their home. So they also just expect this network to just work for internet access, and that's not just in the dorm, but anywhere that they might be meeting with friends, etc. So at the end of the day, we both have to make sure that you can absolutely submit the essay that is due tomorrow, but at the same time, we also have to make sure that you can stream Netflix in 4K anywhere that you are. Of course, we also have faculty as a user group. They also expect the learning management system and the technology facilities in classrooms to work, but they also expect absolutely free and unfettered access to absolutely anything on the internet in the name of academic freedom. And then lastly, we have administrative staff that expect robust data centers and security for their data, just because they, administer things that are personal to students and that mustn't ever be exposed anywhere. So we have clashes because our network is a lot of things to a lot of people. Now I want to talk a little bit about the current state of our network. And I'll focus on wireless first. So it's absolutely true that wireless is the primary access method nowadays. We do IT orientation for freshmen every year as they come in. I usually do some of those classes. So I stood in front of about 200 students this year. And this was the first year where I asked if anybody needed any help with plugging into the wired network, where absolutely nobody raised their hand. There was zero interest. We even made sure, hey guys, we can hook up your gaming PCs or your Xbox or your PlayStation. Out of over 200 people, nobody wanted a wire anymore. Likewise, guest lecturers that come in just want to stream to an Apple TV, and everybody simply wants wireless to work. New laptops come out, they don't even have Ethernet ports anymore. Wireless is absolutely the access method that people use. At the same time, and because of that, we've seen a huge increase in wireless users in the last decade. I started here in the fall of 2011. Back then, we were sitting at about 4,000 concurrent users. Nowadays, we're sitting at 22,000. That is holding steady right now. But we're basically just waiting for the next IT device that everybody's going to have a copy of, and at that point, we'll just be sitting at 4 devices per user instead of 3. Therefore, really the wireless network is what we need to focus on for user access. With these existing legacy controller systems that Jeff was talking about, that it really is difficult to troubleshoot. There's tons of places to look. You've got your DHCP, you've got your DNS, you've got the wireless system itself, you've got your authentication servers. The relevant logs for anything that happened wrong is hidden in a ton of irrelevant information. And even if you write tools that parse all these data lakes, basically, and spit out relevant things to you, you just upgrade, and all of a sudden the log message changed and your regular expression no longer matches, and you're spending the first 6 weeks of term trying to figure out how to troubleshoot all of the freshmen without any help. So while there are dashboards and filters nowadays, they just don't work very well. And the last problem really is that the vendor-provided tools, just because of how they've worked throughout history, they really require a lot of in-depth knowledge. So you can't just take a first-line help desk person and ask them to troubleshoot somebody with an arbitrary wireless problem, simply because really a large percentage of the cases that get handed off to us require interpretation of data that really requires you to go deep into knowing the protocols and having a proper understanding of what all of these disparate log messages mean. And then it's, of course, even harder to actually get to a root cause. If something happens in between class changes, only 2% of people might tell us there is a problem because the rest is too busy wandering across campus. So correlation there makes root cause analysis really, really difficult. On the wired side, if you've ever run a campus network that's developed itself over multiple decades, you know the problem of one-offs. Obviously, we need to support anything that the mission of the college calls for. So if faculty comes with a request, we're probably going to say yes. However, 8 years later, when that breaks, whoever actually implemented it is not going to work here anymore, or the wiki that it was put on has been migrated and that article didn't get moved over. So basically, we often come across configuration out there in buildings where we simply don't know why this even exists. With the current architecture that we have, which is a very simple collapsed core, routed in the core, everything else is layer 2, any new technology or service that we're trying to turn up really needs to fit into this existing architecture. We ran fiber very early as a campus. Dartmouth was a very early adopter of networking. In fact, back in the day, we used to build our own routers out of synthesizer chips. If you ever are up here and want to talk to some of the old guys that did that, they're fascinating to talk to. But due to that, our fiber plant and the way the rest of the network has just inherited settings makes it very hard sometimes to take new modern technologies and just slap them into this architecture that really is not built to support arbitrary things. Because of that, we actually have some parallel networks where requirements don't match. A while ago, the NSF, the National Science Foundation, came out with sponsoring a project basically granting money to higher ed and national labs to build what they call science DMZs, which are networks that are basically just there to facilitate the extremely fast exchange of research data. As we all know, stateful firewalls, IPS, IDS that need to collect context, those are all systems that really slow down throughput. And when you're trying to download yesterday's set from the Large Hadron Collider that weighs in at several petabytes, then 130 megabits per chip on a Palo Alto firewall is not going to cut it. So they basically enabled us to build a parallel network without any of these stateful security devices that we needed to have on the campus network. But now we've got a separate physical network that needs to be funded for upgrades, that needs to be maintained, that needs to be under warranty. And that just becomes difficult. Moving on to our future vision with Mist. So one of the things about this whole AI thing is there's just so many ways to talk about it. AI is a great term that gets thrown about. I always think of actually strong AI, strong general AI when I hear AI. Maybe that's just a bias of me, but most definitely Mist makes incredible use of AI, machine learning, and big data to aggregate logs together. Jeff lobbed me some very easy balls there. Those are the exact problems that we try to solve here. I want the wireless system to tell me that the reason the user had a bad experience is because it took 8 seconds for my DHCP server to respond without having to jump through 4 intermediate systems and a central log collector to figure that out by myself. It's also quite wonderful to be able to define all these SLAs on various aspects of, you name it, coverage or throughput, or how fast it should take to roam between APs, or how long the initial connection to the wireless system should take, and then being able to quickly check when users tell me that they had a poor experience, and knowing that, well, 95% of all users were within the SLA. So now I'm not necessarily looking at a systemic problem. I'm simply looking at this particular user. And the help desk automatically gets very actionable items. At this point, this is actually something where a help desk staff can log in and figure out a large chunk of the problems without handing them off to the network services group. If they do, Mist automatically takes a whole bunch of packet captures so that I suddenly, when this problem gets handed off to me, have a whole bunch of context.
But this leads back to how we're trying to measure ourselves by customer service. We're trying to create the best customer experience we can. Mist allows us, through its analytics, to find out where our problems are, even at the very outreaches of it, the 2% that are having a problem, resolve those on the fly, and create that experience for the customer so that we can move everybody forward.
It does. Also helps greatly with root cause analysis, the way Mist lets you pivot into a problem and then expand it into, did other events like this happen on this access point in this building to other devices running the same operating system, makes it many orders of magnitude faster to get to systemic problems from a single user's perspective. Also, as far as location services go, I mean, the basic stuff is wayfinding and asset tracking, right? Once you've got accurate location services, you can do stuff like follow the blue dot, and you can track a device.
Well, you could do museum tours.
Right.
You've already explored.
Exactly. The fun part is tours,
right.
Is augmented reality.
Computer science, the fact that Mist has open APIs that allows our faculty and students to write apps. I think one of the biggest things we're doing now is people are looking at it for mobile apps. So people are spending, even in IT, spending more time learning mobile programming because they see all these opportunities for developing applications with Mist.
Yep. Yes, we've had great interest from a whole bunch of professional schools about automated attendance taking, letting end users maybe push notifications. Like, why wouldn't you be...
Classroom design.
Classroom
design. So with business school, and also their engineering school, what they want to do is they want the faculty to walk in the room, the students to walk into the room. One, we know the load of the room, so we know what sort of network design we need. And two, that classroom needs to recognize the faculty. We're actually working with Amazon and Alexa to make it voice activated. And we have a couple of people here, Siva and stuff, that are working on tools to integrate that Alexa dot into the classroom.
And then going to the wired side with Juniper. So I'm not going to pretend that we are building a self-driving network here, the stage 5 that Rahul was talking about. We're on step 1, but we're trying to get to step 2, which is kind of the workflow automation-driven approach. And Juniper makes that particularly easy with their API. The XML API via netconf can do anything you can do on the box. What is particularly impressive, even though they've had that feature for years, is if you want to know how to run a command via the API, you run it in the CLI, you pipe it to display XML, and it tells you what kind of API call you would make down to the last XML element.
So for me, what I'm interested in is I like Juniper in the sense that from top to bottom, whether it's at the edge or in the core, I work with one operating system. I also know that they can provide us support across that whole spectrum, even up into security. And what we were looking at from other vendors is they had sort of a hodgepodge, or they really didn't have a core solution, or they really didn't have an integrated solution. And so in the end, when Network made the decision to go, and they chose Juniper, and Mist as a partner with Juniper made this decision a lot easier.
Yeah, what made it easy for us is the orchestration aspect too. Solving the problem of one-off configurations is a huge win. And what we really like is this approach of treating the whole network as just infrastructure as code. The configuration of the network devices is kept in data structures, be it YAML, be it JSON blobs in a database, doesn't really matter. And then taking Ansible, using templates to transcribe them into Juniper configuration, and then pushing that out to the network devices. That basically just means that instead of there's so many ways to document your network, and basically all of them suck, right? At most, you get descriptions on interfaces where you might throw in like a circuit ID or you might throw in a ticket number. And then in variable, 6 years later, you've migrated to the third ticketing system. That ticketing number means nothing anymore, and you've lost all your context. Once you're just at the point where you are just writing data structures that describe your network configuration, it is trivial to add an additional key anywhere that reads comment and then contains arbitrarily amounts of text that describe all of the circumstances around it. And even though you could do that on a wiki somewhere or some other document repository, those things drift. If you've ever run a network for more than 5 years, you will have found that that stuff drifts. So being able to look at that right at the moment that you make your configuration changes is absolutely fantastic. One last note, verification of network state. Juniper has fantastic tools that let you determine the state before a change, then let you apply the change, and then determine the state after and compare the two. So in that sense, we're really looking forward to driving fully automated changes that test themselves and basically just report on everything going well.
So I think our time is up.
I think your time is up too. Thanks for handing it back to me. Hey, and you guys did a great job together, both Mitch and Felix, of sharing your thoughts. I really like the idea that you're not only sort of providing better service to your end users, but by, in an academic setting, by creating this kind of wireless atmosphere, you're also stimulating thought, creativity, and imagination. And I believe that's not just true in an academic setting. I think also if you're in retail, if you're in engineering, if you're in banking, that these experiences make people think about the possible, right? If I knew I could do this, I would ask you to do that. So I think that's a really good point about how this is kind of not just a technical thing we do, but it may be part of the fundamental digital transformation of our organizations. We have a ton of questions here, so I want to try and get through as many of them as I can, and I think I might kind of do this in the order that you spoke. So Jeff, you're going to be up first. And one of the questions we have is a pretty fundamental one, which is why are we calling this AI-driven? I think we're being challenged because, you know, we're doing monitoring, we're logging stuff, and maybe applying some analytics to it. But can we justify calling this AI?
Yeah, no, it's a good question. You know, we do get that often because there's a lot of confusion as to what is AI and a lot of, you know, marketing hype, you know, primarily around other vendors around that. So there's a couple different ways to address that. You know, at the highest level, you know, the definition of AI is you don't know the difference between a computer and a human, right? That, you know, the Turing test. And, you know, so an example of that in our solution is Marvis, our virtual network assistant, where you can actually ask it questions and it'll give you answers we think on par with an RF expert. So that's one example where it's using natural language processing, you know, it's doing all the back-end inference to understand the intent behind the question and coming out with an answer. So I think that's a very clear example of AI. Beyond that, you know, if you kind of, you know, include, you know, data science and machine learning under the AI umbrella, you know, we are using, for example, machine learning for event correlation to collect all those user states and come back and, you know, tell the Felixes of the world, is it a wireless issue, is it a wired issue, is it a device issue. Similar, we're using techniques like anomaly detection with neural networking to, you know, again, detect issues as they arise and predict future issues. Yep. Like, is a classroom potentially going to have a coverage issue next Thursday during test day? So that's another example of, you know, using techniques like mutual information, Bayesian inference, machine learning, which, again, all fall under that AI umbrella. So, yeah, it is a little bit difficult to understand kind of where automation and insight from the old world, you know, is brought into the new world with AI, machine learning, and data science. But, yeah, rest assured, we're definitely using a whole host of those technologies out there. And, in fact, if people want to learn more, we have an AI for IT page on our website, which goes into a little bit more whiteboarding session on some of those techniques we're using.
Yeah, I think that was a hearty defense, especially talking about, again, being able to do things predictively based on correlations that we're not providing our own expert rules for. I mean, that's the very definition of machine learning. Rahul, I wanted to send a question your way, and we got a couple of questions like this, which is, what do you say to network folks who are concerned about losing control to automation? So we've discussed all the advantages, but isn't there kind of this nagging concern that, you know, the quote-unquote brain of the network will make some kind of mistake, and that mistake is sort of inherently difficult for the team to quickly pinpoint and fix because it's a mistake in the unseen, indeterminate analytics rather than in, the infrastructure bottlenecks and breakdowns per se that we're used to diagnosing. Any response you have to that, Rahul?
Yeah, absolutely. And I think that's very germane to this discussion. If you look at it, most of the network problems that we see are caused due to human error. Sometimes we have a remote branch and someone misconfigured something and they lose connectivity to the branch. The only way to get is to pick your truck out through snow and go 20 miles and go and fix it. So there's some of those things have already been fixed in Junos because it's config rollback kind of features. You can actually do some idiot proofing in the network, right? With advanced analytics we can do is you can, depending on where the customer wants to put them in that 5-step process, the simple problems that we have learned that we've seen, 50 other customers did this and this is working fine, or I have few customers that have made this mistake, and based upon that I can tell you that this particular problem needs to be fixed right now because that will potentially be a train wreck at a later point. So that can be, those are things that can automatically be fixed with low risk, right? And then there are things that are more involved, that requires a lot of analysis, and in those cases, that's why I mentioned when I broke it down into 2 pieces, where network can be proactive and fix the things by itself, and then it can provide actionable insights and say, based upon all the parameters, my machine learning engine is advising that you take this specific action. Now, in those cases, we don't take the action. So it sort of gives human control, but not boatloads of data to analyze because we don't have that much time to do it.
Yeah, it's quicker time to action and more security in the decision. Felix, I might send that question your way too, since you're the one who's actually responsible for this and will probably be beaten by Mitch severely if something goes wrong. How do you feel about this amount of automation, and do you have some concern that you might actually be able to end up just reading a book and napping because the AI does so much for you?
That's what I want to get to. I prefer reading to many other things in life. No, on a serious note, I have been championing automation here at Dartmouth. It's useful from 2 aspects. From a purely selfish aspect, it is far more fun for me and far more interesting for me to work on general cases and automation, and then have trivial, boring stuff be solved by other people or by machines. At the same time, Dartmouth benefits from that because, to Raul's point, once you've done something, once you've seen an event happen and then reacted the same way 50 times, why would you be afraid of just automatically doing that on the 51st time? Machines are going to be able to react faster. They're going to be able to react more accurately. And I genuinely don't think that this is going to write me out of a job because at the end of the day, it's not, my campus network is unique, even within, say, the Ivy League. So no matter what Juniper and Mist give me, you're still going to need an expert that is actually going to either train that system or write the appropriate response playbooks. And that is a far more interesting job than upgrading switches or moving traffic from one link to another.
Yeah, absolutely. It's a better allocation of your talent, which is expensive and hard to find and retain. So I think there's also a retention element there that a lot of us are experiencing, in technology, where folks who really know stuff have the ability to get paid a lot of places in different, right, and move somewhere else. And to keep them retained, you want them working on something besides just reconfiguring subnetting. Mitch, I want to send a question your way, which I think may be relevant to a lot of our attendees. So all of this sounded really good in terms of benefits and better experience for the user, et cetera, et cetera. But we still need to shake budgets loose for redoing a Wi-Fi network that the CFO may have seen us already investing a lot of money in. How did you go about sort of consensus building across the multiple stakeholders? And did you have to, any particular advice you might have with some of us who are sort of are becoming believers but aren't sure about converting some of the stakeholders who hold the strings?
Well, I think it's do your homework. So prior to taking the job, I gave them basically an introduction into technical debt and what that meant for them and where they were.
Mm-hmm.
So I sort of prepared them when I walked in the door that there was going to be a large discussion about decisions that had been made in the past and the way they were treating technology as not as an investment or strategic investment, but as just a service that could be dragged out with little understanding. So once I started there, it was pretty easy to build a whole cohort of faculty and staff that were very interested in making sure that Dartmouth was up to date and what it was doing, and that we were building systems that made a difference. And so I would say that I'm the largest salesperson on the campus, is that I'm constantly out. I think as a CIO, if you're not the salesperson for the organization, you're probably not doing your job. Doing the marketing, making sure that people are on the same page, and then talk about a future that's different than the one that they have today. And then also talking with your staff to make sure that they're on board, that that future is a much better one than the one they presently have. Because really what you'll notice is that a lot of institutions haven't made a solid investment in new technology. What they do when they go to make a decision is they usually buy into what they have.
Yep.
And that may not be the right decision at that time. So then if it's all new, how do you sell that? So at Dartmouth, I've been here a month, 1 year, 2 months? And I've been able to sell this across the campus as sort of a next generation network, and that this investment from Juniper up to Mist is a strategic one for the campus for a whole host of reasons, given that we're in research, high performance computing, and as far as risk associated with that, that's their biggest risk, the disconnection from the internet. In the past, we haven't seen that. When's the last time we were down?
Best to my knowledge, Hurricane Irene, summer 2011, a couple of months before I started. In my 7+ year tenure, I've not seen internet out.
So the stability that they expect is really high, but wireless hasn't been as solid as we'd liked it to be, and that's because of an underinvestment. The wiring that was done across the campus was an underinvestment. But they know all of that, and then we built a software application that basically takes all of our hardware in and creates a model of what the spend rate is for Dartmouth just to maintain the technology that they have. And now the CFO, the president, and EVP, provost all have access to that, and now they know a number that we're supposed to be saving every year just to pay for the technology they have. And I would say that's the biggest thing. Now we can have a real conversation. Prior to that, nobody knew.
Yep. And I think it's really good, again, to associate this not just sort of with the blocking and tackling of delivering services, but something strategic for the brand, because certainly brand is very important to Dartmouth for researchers and students. You're in actually a highly competitive business competing for talent and brains, so I think you've done well by your brand. Hey, we're getting by the top of the hour, so if we haven't gotten to your question yet, don't worry. It's in the queue. We just won't be able to answer it in the time allotted. We'll answer it offline, though, because we have your email and your question. Maybe just a couple of real quick, like 1 minute, 45-second final words. Jeff, you first. Maybe you want to answer one of the questions or just leave everybody with a thought?
Yeah, I mean, I appreciate that, Lenny. Again, I think, the thought is to kind of wrap up what I said at the beginning is, we're in a new era right now around automation and insight. And, it's taking vendors like Mist and Juniper working together. It is taking new technology like AI in the core. And we just, welcome working with customers/partners like Mitch and Felix who, see the big picture, are able to look around the curve and implement these types of technologies. And so we're just really excited on working on projects like this.
Yeah, I think you've definitely triggered a lot of thinking with our attendees and myself as well. Rahul, I'm going to give you a chance again, just 1 quick minute if there's anything you want to share in closing.
Yeah, absolutely. Thanks, Lenny. So the last thing I want to say is, no matter where the enterprises are in their multi-cloud journey, be it 1, 2, 3, picking the right solution that takes them through this journey towards the final eventual goal is extremely important, and the solutions from Juniper and Mist together can help them in getting towards that journey.
Yep. Yeah, I just really appreciate all of you, Jeff, Rahul, and also Mitch and Felix for opening our eyes and getting us to think about how much more we can do with wired and wired networks that are not only fully sort of virtualized with function, but also are driven increasingly by some machine intelligence we can get on them. I just have to let everybody know real quick in closing, though, that within the next 24 hours, you're going to receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to share that across your organization. Like Mitch says, you got to sell this stuff internally to the people you report to, those who report to you, and some of your peers in the organization. So invite your colleagues and peers who haven't been able to listen to the event live. I also have to tell you that the webinar is copyright 2018 by UVM, with the presentation materials are owned by or copyrighted by Information Week and MIST Systems and Juniper Networks and our friends at Dartmouth, and the individual speakers today are solely responsible for their content and their opinions. So on behalf of Jeff and Rahul and Mitch and Felix, I'm Lenny Liebman. Please keep your eyes peeled if you found your this time today worthwhile for future events. And thanks for your time. Have a great day.